Learning Chem 20. Today we're going to finish off the stoichiometry, the gravimetric stoichiometry questions that you were doing with Ms. Walsh yesterday. Today we are going to look at an example where we're given a mass of one reagent to determine the mass of another. So just remember, we are doing this, think of it like if you were cooking a recipe and you were limited by one ingredient, you would then have to go through and figure out how much of the other ingredients you would need. Let's say if you had to half the recipe, or maybe you wanted to double the recipe, you'd have to go through and figure out how much would you have to, how would you change all the other ingredients measurements in order to make the correct recipe. So same idea here, except you guys were introduced to that mole ratio yesterday. So we're going to do example number 5. We are going to be given a mass of one reagent, and we are going to determine the mass of another reagent within the reaction. So a student made the following observations in an experiment where a strip of copper, so we have solid copper, was placed in an aqueous solution of silver nitrate, and we are going to assume that the products are aqueous copper 2 nitrate and silver metal. So we can write out our equation for that. So we have a strip of copper, so Cu solid, plus silver nitrate. So silver is Ag1+, and nitrate is NO3 negative. So our formula will be AgNO3, and it will be aqueous. We are going to have a single replacement reaction occur. So the copper is going to swap out with the silver. So silver is now going to come out of solution and become solid, and our copper is going to replace it with the nitrate. So remember, they told us this copper is copper 2, so we're going to use copper 2+. So that's going to make our compound NO3 bracket 2, and they tell us that it is aqueous. So now we're going to go through and balance. So currently right now we've got one copper on both sides of the reaction. We have one silver on both sides of the reaction. But now if we take a look, we have 2 nitrates and 1 nitrate. So I need to put a 2 in front of my silver nitrate, and then that causes me to also put a 2 in front of the silver. So there's the balanced equation for the reaction. Now we need to determine the mass of silver nitrate. But first, take a look at this information here. They are telling us the initial mass of our copper strip, so before we put it into the solution. And then at the end of the reaction, they tell us the mass of the copper strip afterwards. So if we want to find the mass of the copper that reacted, we have to subtract the two values. So 2.97 grams, and we're going to subtract from that 1.54 grams. We are going to get 1.43 grams of copper. So we can take that mass now, and we can go mass of our copper is equal to 1.43 grams. They want us to solve for the mass of our silver. So under our silver on the product side, we're going to put a question mark. And again, in order to do this, we need to use that mole ratio. So we need to figure out how many moles are in our copper, or how many moles of copper are we starting with. So in order to do that, we need our molar mass. So if we take a look, the molar mass of copper is 63.55 grams per mole. And we're just taking that off the periodic table. Then, if we want to solve for moles, we're going to take number of moles of our copper, or to solve for the number of moles of the copper, we're going to take our mass, 1.43 grams. We are then going to multiply it or multiply by the inverse or divide by our molar mass. So moles are going to go on top. 63.55 grams will go on the bottom. So now we know the number of moles of copper. So take 1.43 in your calculator. You are going to divide it by 63.55 grams. And what you should get is 0. 0.02250 moles of copper. So that is the number of moles of copper. So now we're going to use the mole ratio to solve for the number of moles of silver. But before we do that, we can just write down what is the molar mass of silver. So we have 1 atom of silver. So you're going to look up on your periodic table and you're going to find out that 1 atom of silver has a molar mass of 1.7 times 10 to the 87 grams per mole. Now if we want to solve, we need to use that mole ratio to solve for our moles of silver. So our number of moles of silver, let's take the number of moles of copper that we are consuming. So 0.02250 moles of copper. And now we're going to use that mole ratio. So we want to know silver. So we're going to take the 2 Ag silver because that's what we're solving for. We are given 1 mole of copper, so we have a 2-to-1 relationship. So we'll put 1 mole of copper on the bottom. The coppers will cancel out. So if you take 0.02250 and you multiply it by 2, divide by 1, you will get 0.0450039 moles of silver. So we are still looking for the mass of our silver. So if we want to solve for our mass, take the number of moles, 0.0450039 moles, and now we're going to multiply by our molar mass. 107.87 grams divided by a mole. So moles will cancel, and we're left with mass. So plug that into your calculator, 0.0450039. Multiply by 107.87, and you will have 4.854 grams of silver. Take a look at your significant digits. All of our digits are up here, and the masses that we were given, we have 3. So our final answer is going to be rounded to 3 digits. So the mass of the silver produced will be 4.85 grams of silver. And that will be our final answer. Okay, so in a moment, I'm going to go through some solution stoichiometry with you guys as well today. But when we're done the entire video lesson, you guys can come back and you can start this assignment here in your textbook. So page 278, numbers 8 to 15. Okay, so we're just going to flip over now. This gravimetric stoichiometry worksheet, you guys will have time to work on that tomorrow in class. Tomorrow in class on Thursday. We have a shortened period with mass. So you'll be able to work on this worksheet. We'll have a work period. We're going to move to solution stoichiometry so you kind of get the idea of how to do the same kind of mole ratio questions, but now with solutions. And then you guys can work on some more problems on your own. Okay? Okay, so here we go. Same idea, but now instead of being masses that we're dealing with, we are going to be dealing with solutions. And so we're going to have concentrations and volumes instead of masses that we dealt in that gravimetric stoichiometry. So we're now going to look at our equation for solutions, right? If we look at our equation C equals N over V, we've now just manipulated it to be N, the number of moles that we want, is the concentration of our solution, times the volume of our solution. So let's take a look at example number 6. This is where we're going to look at the concentration of we're going to determine the concentration of one of the reagents if I give you the volume and concentration of another reagent. Okay, so just like all the other ones, we're going to start out by writing out a balanced equation, and then we'll list everything underneath each reagent that we get information for. So we want to determine now in example 6 the concentration of 20 mils of sodium hydroxide that's going to react with nitric acid in a neutralization reaction. So sodium hydroxide, sodium is Na+, hydroxide is OH negative, so we will have NaOH, and that will be aqueous, plus nitric acid, which is one of our, which is HNO3, and that is aqueous. And then we're going to go through a neutralization reaction. So if you remember from our previous lesson, we will produce water, HOH, plus the salt, so the sodium nitrate, NaNO3. So you can think of it kind of like a double replacement. So the water is going to be liquid, and the sodium nitrate will be aqueous. And you can check your solubility table again. So let's write down now what they gave us. They told us that we are determining the concentration of sodium hydroxide. So this is our question mark. What is the concentration of sodium hydroxide that is going to react with 10 mils of nitric acid that is 1.5 moles per liter. And I just forgot that they told us the volume of sodium hydroxide. So let's write that down first. 20.0 milliliters. They told us the volume of nitric acid is 10.0 mils. And the concentration of the acid is 1.5 moles per liter. Okay, and again, make sure you take a look at your equation and make sure it's balanced, which this one is. So we don't have to do any coefficients in front of any of our reagents. So now we can solve for the number of moles of our nitric acid, and we're going to be using this equation up here. So number of moles is the concentration times the volume. So number of moles of nitric acid will be our concentration, 1.5 moles per liter. Now take a look, that's in liters. So we have to convert our 10 mils to liters. So this will be 1 liter, and we're going to divide by 1,000 mils, which will make this 0.01 liter. All right, 1, 2, 3. So let's multiply this by 0.01 liters. Liters are going to cancel, so all we're left with is moles. So 1.5 times 0.01 is going to be 0.015 moles, and this is the number of moles of nitric acid, HNO3. So we're looking for the concentration of sodium hydroxide. So we now have to use our mole ratio to figure out the number of moles of sodium hydroxide. So if I have 0.015 moles of HNO3, I'm now going to multiply by my mole ratio, which is 1 hydroxide to 1 nitric acid. So 1 NaOH to 1 HNO3. So I'm going to have the same number of moles of sodium hydroxide to nitric acid. It's a 1-to-1 ratio. Now we're going to take our number of moles. We're going to divide it by that volume. So we're going to use this equation here to solve for our concentration. So I am just going to move this over here. So I'm going to solve for my concentration by saying 0.015 moles of NaOH divided by my volume. And again, let's convert that into liters. So 0.02. So 0.02 liters. So 0.015 divided by 0.02 is going to equal 0.75 moles per liter. And then if we take a look at our significant digits, I have 2 sig digs here, I've got 3 here, and 3. So I'm going to finish my answer by rounding to 0.750 moles per liter. And if you wanted to write that in scientific notation, you could, but on a short answer, you don't have to. You can just write it like that. Oh, sorry. And actually don't need that extra 0. I'm just going 2 significant digits, so 0.75 moles per liter. Okay, let's try example number 7 then, determining the volume of one reagent given the concentration and volume of another. So now I want to know how much of a solution I need if I know the concentrations of the 2 solutions. So example number 7. Determine the volume of 0.05 moles per liter of silver nitrate solution required to react completely with 50 mils of 0.25 moles per liter of magnesium chloride. Okay, so we got to take our silver nitrate solution. So silver is Ag+, nitrate is NO3. So that will be AgNO3. And they tell us it's in solution, so we'll make that aqueous. We are going to add it to magnesium chloride. So magnesium is 2+, chloride is 1-. So that will become MgCl2, and that will be aqueous. And we are now going to react the 2, so this is going to be double replacement. So the silver is going to switch spots with magnesium. So now I'm going to produce Mg bracket NO3 aqueous plus AgCl, and we're going to check our solubility table, because what you're going to find is that the silver chloride is actually going to precipitate and become a solid. And now if we take a look at our reaction, we have to balance it. So 1 silver on each side, but now the nitrates are not balanced, so I got to put a 2 in front of silver nitrate. That means a 2 has to go in front of silver chloride. And then if we take a look, everything else is balanced out. Okay, so let's take a look here. They told us that we have a concentration of silver nitrate, which is 0.050 moles per liter. We want to determine the volume of that silver nitrate, so that's our question mark. And they're telling us that we're going to react with a volume of magnesium chloride, that we have 50 mils. And if you want, we can convert that right away. 1 liter over 1,000 mils, 0.05 liters. And the concentration of this is 0.25 moles per liter. Okay, so if I want to know the volume of my silver nitrate, I first have to solve for the number of moles of magnesium chloride. So again, we're going to use the equation number of moles is my concentration, 0.25 moles per liter. And I'm going to multiply by my volume, 0.05 liters. So liters will cancel. So now I know the number of moles for my magnesium chloride is going to be 0.25 multiplied by 0.05, and that is going to give me 0.0125 moles of MgCl2. So now that I know the number of moles, I'm going to use my mole ratio between magnesium chloride and my silver nitrate to solve for the number of moles of silver nitrate. So 0.0125 moles of MgCl2. I'm going to multiply it by 2 moles of AgNO3. Divide by 1 mole of MgCl2. So again, remember, this is just coming from the coefficients. So I'm going to take 0.0125 moles, multiply it by 2. So I'm going to have 0.025 moles. MgCl2 cancel, so I'm left with AgNO3. And now I need to solve for volume. So if I want to solve for volume, and I know the number of moles, 0.025 moles, I'm going to take my concentration and I'm going to, what you could say, divide by it or multiply by the reciprocal. So we're going to divide by 0.05. And now our volume, is going to be 0.5 liters of AgNO3. And then I'm going to take a look at all of my significant digits. I have 2 here, 3, and 2. So we're going to round to 2 digits. So my final answer will be a volume of 0.50 liters of AgNO3. And that's going to be my final answer. Okay, so I just have one more example here for you guys to do together, and then there's a second textbook assignment here at the end that you can work on as well. And then again, tomorrow will also be a work period. Okay, let's try 7b here. Sulfuric acid is a dipropic acid that reacts with potassium hydroxide to produce water and aqueous potassium sulfate. If 10 mils of sulfuric acid is completely neutralized by 25 mils of 0.5 moles per liter of potassium hydroxide, determine the concentration of the sulfuric acid. So let's start with our reaction first. So we have sulfuric acid reacting with potassium hydroxide. We are going to produce water and aqueous potassium sulfate. So sulfuric acid is H2SO4. We are going to react it with KOH, aqueous, and we are going to produce water, HOH, liquid, plus potassium sulfate, K2SO4, aqueous. So let's go through and balance. I've got 2 hydrogens on the reactant, so I need 2 waters. That makes 2 hydroxides, so I need 2 potassium hydroxide. And then if I take a look, my potassiums are now balanced 2 and 2. Next step, let's list everything that we know. So the volume of sulfuric acid is 10.0 mils. We are going to neutralize it with a volume of potassium hydroxide of 25.0 mils. And the concentration of our potassium hydroxide is 0.50 moles per liter. We are solving for the concentration of our sulfuric acid. So let's first solve for the number of moles of potassium hydroxide. We will then use our mole ratio, and then we can determine concentration. So let's start. How many moles of potassium hydroxide do we have? So number of moles, take our concentration, 0.50 moles per liter. We got to convert our volumes to liters. So we're going to divide those mils by 1,000, 0.025 liters. So multiply the concentration by 0.025 liters. And we have a concentration of KOH of 0.0125 moles of potassium hydroxide. So we're going to take the number of moles of potassium hydroxide, and we are going to use our mole ratio to solve for the number of moles of sulfuric acid. So number of moles of sulfuric acid, 0.0125 moles of KOH. Now, let's take a look at that mole ratio again. So I want to get sulfuric acid. So I have 1 mole of H2SO4 to 2 moles of KOH of what I know. So this should be 2 moles of KOH. So the KOH will get eliminated. So now I know the number of moles is 0.0125 divided by 2, which comes out to, on your calculator, it may have come up as scientific notation, 6.25 times 10 to the negative 3 moles of H2SO4. I'm looking for concentration, so now if I know the number of moles of sulfuric acid, let's take this volume of sulfuric acid and we're going to convert it into liters, so 0.01 liters. So now if I want to solve for my concentration, 6.25 times 10 to the negative 3 moles. I'm going to divide by 0.01 liters, and that's going to equal 0.625 moles per liter of H2SO4. Let's take a look at significant digits. I've got 3, I've got 2, and I've got 3. So we're going to round to 2 digits. So my final answer will be 0.63 moles per liter of H2SO4. And that is the final answer. So, same kind of steps through everything, just depends on what we're giving you. If we're giving you mass or if we're giving you volume, we've got different equations. So you have the molar mass equation we can use, and you have your concentration equation you can use, molar concentration, that we can use to find number of moles. So just remember, write your balanced equation, list everything that's given to you, plus what's your unknown, so what's the question mark. Then you're going to solve for the number of moles for one of the reagents that you have enough information for, then use the mole ratio to solve for the number of moles of the other reagent, and then you're either solving for mass or you're solving for volume or maybe concentration. Okay, so you have two sets of practice problems here. You can do the assignment on page 182, and the other assignment is on, it's on page 9 of your workbook. So the assignment pages are page 278, questions numbers 8 to 15. Okay, so you can work on those today, and then tomorrow we'll have a full work period. I'll be back and I can help you with any questions that you have.